All right, at last we're at the empirical rule. We're going to tie together the idea of the percentile score and the z-score and where that puts us in a population. It's a great rule. We're going to be using it a lot throughout the rest of the semester, so we really want to spend some time on this. Probably going to take 2 of these lectures to deal with it. The empirical rule says in a population that is normally distributed, meaning the majority of our population is in the middle around the measure of center, and it's spread out so that the population tapers off as we get away from the center. Let's talk about that for a second. Talk about heights. You look at the number of people between 5 and 6 feet tall. There's a lot of them. The majority of the population falls between 5 foot and 6 foot. So if we were to graph the population between 5 and 6, we'd have a fairly tall graph. We have that bulge in the middle of our bell-shaped curve, which I'm sure you've heard of. As we move out farther and farther from the mean, down to 4.5 feet or up to 6.5 feet, there are some people at those heights, but there's not as many. We refer to those as the tails. So we have the hump in the center of the population where the most people are, and then as we move away from that, we have fewer and fewer people, or trees, or dogs, or anything in nature. If it's normally distributed, we have that cluster in the middle, and as we move out, we have the tails, we have that bell-shaped curve. We'll deal with that much more later in the semester. For now, just understand if the population kind of looks like that, then the empirical rule applies to it. And the empirical rule says, if we look within 1 standard deviation of the mean, we will find 68% of the population. So let's go back to the IQ example. The mean is 100. That's by definition. We don't get that from anywhere. IQ tests are defined or designed to make the average be 100, and the standard deviation is 15. So if I go up 1 standard deviation from the mean and down 1 standard deviation from the mean, I will capture 68% of the population. Or, another way of saying it is 68% of the population falls within 1 standard deviation of the mean. So 68% of people have IQ scores between 85 and 115. Another way to think of that is that since there's symmetry here, 34% are between 100 and 115, and 34% are between 85 and 100. Okay, that's part 1. 68% fall within 1 standard deviation of the mean. Part 2, if we go out 2 standard deviations from the mean, we're going to catch 95% of the population. Or 95% of the population fall within 2 standard deviations of the mean. Okay, so in the context of IQs, 95% fall between 70 and 130. And if you remember, those numbers are the cutoff points to be considered outside of the range of normal, diagnosed as either gifted or on the other end. I don't want to use the words there because they always manage to piss some people off, and rightly so. So we'll just leave that unsaid for the moment. But 70 is the cutoff for certain diagnosis, 130 the cutoff for the other. And that leaves 95% of the population in the middle, right? Only 5% fall outside of those, which would be 2.5% on each end. So we got 2.5% down here and 2.5% up here. The third part of the empirical rule says virtually all fall within 3 standard deviations of the mean. So if we go up to 145 and down to 55, virtually the entire population falls within that range. Now, numerically, virtually all is actually 99.7%. So there are, obviously, a very, very small number of people down here and a very, very small number up here, but we're only talking 2 or 3 per every 1,000. So we say virtually all fall within 3 standard deviations of the mean. Okay, that's the empirical rule. I want you to have it memorized and I want you to understand it. And before the next one, I'm going to come back and numerically figure out how many that puts in those little pieces there. But in the next video, we're going to talk a little bit about how this relates the percentile score to the z-score, right? If you have a z-score of 1, you're 1 standard deviation above the mean, which means you're here. And according to the empirical rule now, we can then calculate your percentile score by knowing what percent fall below and what percent fall above. And we will get to that next time.